exploring COVID-19's effect on the worsening of climate disruption in the context of climate warming. I'm pleased to announce that today's event is part of the David R. Kotok Global Healthcare Series. And on behalf of everyone here at GIC, I would like to express our appreciation and thanks to David for his generosity. As a reminder, and I'm sure that many of you know this, this event is recorded and you can access it as well as the slides that will be presented on the GIC website. So for today, we are joined by Bob Bunting. Bob is a scientist and a serial entrepreneur, high technology startup expert, and an educator. He is the CEO of the new Climate Adaptation Center, or otherwise known as CAC, which is dedicated to providing a curated database and situation analysis in 4 topical areas impacted by the warming of climate. The first one seems fairly obvious, rising sea levels. Second one is red tide. The third one is the changing characteristics in hurricanes. And the fourth one is human health. Bob holds a Bachelor of Science and a Master of Science degree in atmospheric science from St. Louis University. In his presentation, Bob will discuss, it is time to move forward with regard to adaptation and mitigation until global solutions emerge in the decades ahead. Now, against the backdrop of all the hurricanes that we've seen thus far this year, as well as the fires out west, one would think that this gives us a glimmer of hope. So I don't want to delay this any further. Bob, your virtual floor is here for you. Thank you so much for joining us.
Oh, my pleasure. Thank you, Kathleen. And I'm looking forward to discussing climate warming in the context of COVID and human health with all of you. We can start with the slides, please. So the Climate Adaptation Center is our new center. It's geared toward really discussing how science can impact our approach to the disruptions of climate warming. Unfortunately, in the past, we've had a lot of great science, but we haven't really had the ability to really translate that science so it can be used easily by the 3 sectors in the economy, basically the private sector, academe, and government. And in order for our message to get across, we need to do a better job in communicating the vast science that we have around climate change, because it's time to act now, and I think everyone is starting to see that. The CAC is the first institution of its type. It's local, it's focused on Florida and the west coast of Florida specifically, and this is a prototype CAC. Hopefully we'll prove this business model, and then these CACs will proliferate all over the world. And in order to do our first prototype, we are raising $2 million to kick off our mission. Next slide, please. So today we're going to talk about you know, my slides are so big I can't really see them. Let me see if I can fit to the window here. Here we go. We're going to talk about warming temperatures, of course, because that's all what it's about. And we've seen record heat waves this year across the United States, but not just here, across Australia, across the Antarctic, across the Arctic, and we've had forest fires. I'm going to talk about the ones here in the US, but when it's not limited to the US. Hurricanes, a record year going on. We've had 20 storms already. The record is 28. At the rate they're forming, this will be the largest hurricane season in history. And then I'm going to lump everything else into one topic and then talk a little bit about the missing link to action, and then hopefully end on a high note with hope springing eternal. And basically, I believe that we've been pushing from the high levels for 35 years without a lot of success in the world, and now we really need to push from the local level on climate adaptation and mitigation. Next slide, please. So this is the stripes. You may have seen this before. On the left side of the diagram or color chart is 1850, and on the right side is 2019. And each stripe represents a year of time, and it's color-coded from blue to red. And when they say a picture is worth 1,000 words, this is one of those pictures, because you can see on the left-hand side, 1850, 1900, we basically are mostly blue stripes, a little variation. But starting in about 1900, we see the colors lightening more toward a light blue, and then finally pink, and then into the heavy reds, which we're having now. Since 2000, most of the hottest years in climate have been since 2000. So it seems when you look at the data that it's indisputable the climate is warming. We might argue about why, but we can't argue that it isn't. Next, please. So besides getting hotter, the Arctic and Antarctic are warming 3 to 4 times faster than the temperate zones. And as this temperature gradient from the equator to the pole weakens, so do the jet streams that move the weather around. And this is significant for big storms like hurricanes. Some of you may know this, but it might surprise a few of you that nighttime temperatures are warming quite a bit faster than daytime temperatures around the world. And of course, as the heat builds, the land masses are drying out, and that's creating drought and the forest fire proliferation that we're seeing. The oceans actually are absorbing about 94% of the excess heat so far. And that's because they're deep, but they're getting warmer. And as they're getting warmer, they're having a high impact on hurricane formation and sea level rise due to thermal expansion and, of course, melting the glaciers in the Arctic and Antarctic and Greenland. Next. Here's a picture of Colorado. That's where I'm sitting right now. And we've had our share of forest fires this year. If you look across the eastern part of Colorado and southwest Nebraska, you'll see cumulus clouds. But just to the west of that, you see these smoke plumes. And if you look closely, you can actually see the flames. There's 1, 2, 3, 4 in a row as you go from the northeast part of Colorado toward the southwest part of Colorado. And we've had a record forest fire season in Colorado already, with 2 of the largest fires in Colorado history and about 400,000 acres of Colorado burned. If you look to the right, southeast side of the picture, you'll see the smoke plume as it moves out from Colorado into Kansas and Texas and Nebraska. And we certainly have had very poor air quality across much of the nation from these fires. Next. here are the California fires a few days ago. This is quite dramatic, as you might remember that 2 weeks ago or a week and a half ago, we had 101 degrees in Denver, and the next day we had 7 inches of snow. And as that record cold came down, it was the greatest temperature change in 12 hours in Colorado history in September. It set up the Santa Ana winds in California that blow offshore, and you can see how the smoke plumes blow into the Pacific, and then they eventually work down to Southern California and then come back over the United States. And those are all the fires in California. You can actually see the heat coming up from them. Just incredible. 5 million acres burned in 3 states in the last few weeks. Next. So we're having a record number and extent of forest fires in the Western USA. There's not only more, but they're bigger. The cost for fighting these fires is rising very fast. We have 30,000 forest fires right now in a COVID situation, working in very bad conditions, sometimes rescuing people, and sometimes very close together in an incredible, almost surreal situation that's going on. Record life and property losses, about 7 million acres burned across the US in this fire season. That's the size of Rhode Island and Connecticut put together, and then a little bit more. 10,000 structures burned, most of them homes, and a death toll now over 78 from these fires. I'm sure there's going to be questions about, is this just climate warming? And the answer is no, it isn't. We have poor zoning that's contributing to these fires. And what I mean by that is, take California, for example, 43 million people living in a high desert with not much water and moving into the trees and scrub brush was probably not the, it might actually, should maybe be voted as one of the possibilities for this year's Darwin Awards. Not too smart. The second one is we've had poor forest management. A 15-year drought in California has killed millions and millions of trees. The forest managers have wanted to let those trees lie fallow so the natural environment goes to work. But it's very hard to do that when you have millions of people living in those heavily diseased areas where the trees have died and not been chopped down. So because they haven't been cleared, and because we have people living in these areas, it has not been a good combination. Next. We're not the only ones. Early in January this year, this is a simulation of all the fires in Australia that you heard about. Excuse me. It was a record season there as well. And their season is earlier than ours because they're in the Southern Hemisphere. And so their turn is coming up again in a few months. Next slide. Now this is talk about forest fires and hurricanes, which are the 2 big topics today. I could talk about many more things, but in a short time, I didn't want to overburden the conversation. So here's a GOES satellite picture, and you can see the smoke from the California fires, just terrible air quality on the West Coast, the worst air quality in the world for the last few weeks, worse than the cities in China from industrial pollution. And of course, this is a few days ago, but Hurricane Sandy was forming over southern Florida, and today is striking the Gulf Coast with a variety of wind, flooding, and heavy rains. The Sandy is one of these hurricanes that is being impacted not only by a warming sea, but also by the weakening jet streams as it's stalling out as it's approaching the coast, and could cause not only major storm surge, but major flooding as 25 to 30 inches of rainfall in the next 2 or 3 days. Next. So hurricanes are experiencing character changes as the sea surface temperatures rise. That 94% of the excess heat from global climate change and global warming is going into the oceans. And we've seen these things which in NOAA they call rapid intensification. And I don't think that captures what's going on anymore. So I call it explosive development cycles. Since 2017, we've had 6 Category 5 hurricanes. And of course, we just had Hurricane Laura strike the Gulf Coast. It was the fastest spin up of a hurricane ever measured. But within 24 hours, the winds increased by 65 miles an hour. What we're also seeing are the eyes of these storms as they form are getting smaller and smaller. Irma, Maria, Michael, Dorian, and Laura in the last few years, all hitting the United States or the Caribbean, have all had pinhole eyes, sometimes 10 miles in diameter. So when these hurricanes go ashore, they're more like large tornadoes than they are hurricanes, because the winds are so tightly packed around their eye that they wipe out everything they go over. And because the jet streams are slowing down because the gradient between the poles is decreasing as the poles heat faster than the equator, we have Harvey, Florence, and today Sally, which are slowing down more often and creating epic flooding. Next, please. This is a picture of the infamous Hurricane Irma. And if you could click on that picture, it will start, go back one. Just click right on, there you go. This is a loop as it moves through the archipelago of Cuba. Oops. Here you go. And you can see how small that eye was. And that one was about 15 miles in diameter. That was a Category 5 hurricane at that time. It went right over Barbuda and totally destroyed that island. And if it wasn't for the fact that Cuba got tangled up with that eye, Florida would have had 10 times more damage than it did, and it was bad enough as it was. Next, please. So the economic losses are mounting from winds and floods due to hurricanes. As I said, we've had a record number of hurricanes at Cat 4 and 5. And in our COVID world, because it's difficult to social distance and evacuate millions of people, like we did in Florida for Irma, 6.5 million people were evacuated for Hurricane Irma. I believe it was the largest evacuation in a short time in human history. If we had to deal with that today in a COVID situation, we would not be able to evacuate that many people. And not only that, but with explosive development cycles that could occur close to coastlines, there may not be time to evacuate. So this is a strategic planning issue for governments at all levels that is under served right now. It's under talked about, and this could be a mass casualty situation in the future if we don't start working on this problem soon. Of course, we're seeing increasing cost of wind and flood insurance everywhere. It's just not along the coastlines. It's also in California due to the Santa Ana winds blowing the fires. It's amplified by poor zoning for hurricanes as well as for fires. And certainly because we have poor coastal zone management as our American coastlines are being severely eroded by rising sea levels, and then bigger storms that bring bigger storm surges along the coast. Next. This is a picture of the pinhole eye of Hurricane Dorian, one of the strongest hurricanes in history, just as it was going over Abaco Island, practically submerging the whole island and destroying 90% of it. If it didn't stall, it would have probably hit Florida. This is one case that worked in the favor of the United States, but that looks pretty much like a tornado, doesn't it?
Mm-hmm.
Next slide. Here's the path of Category 5 Hurricane Dorian. And the colors, when you see it red, that's when it was Category 5. And you also see the distance between the dots. That's how fast it was moving in 6-hour increments. And you can see as it approached the United States and the Bahamas, how it stalled out. And that's why the damage was so severe, because they had hours and hours of winds well over 150 miles an hour gusting on the Bahamas. Just a nightmare scenario. Next. This is Hurricane Michael that came up through the Gulf Coast, went over the loop current, which is a current in the Gulf of Mexico that sometimes can be 5 degrees centigrade warmer than the surrounding air, water. And right now, for example, in the Gulf of Mexico, the average temperature of water is 88. So imagine a hurricane going over 92-degree water. It just sucks in that energy and spools up into these rapid development cycles with these pinhole eyes. Hurricane Michael hit a sparsely populated part of Florida and did epic damage, knocking down thousands of square miles of trees, which are lying there right now waiting to burn, and destroying billions of dollars worth of real estate along the coastline. But had this been Tampa instead of Mexico Beach in Florida, it would have been unimaginable, a $1 trillion storm, and it's coming. Next. This is Category 4, the pinhole eye of Laura as it was approaching Louisiana. The part of Louisiana it hit was sparsely populated, but had 300,000 COVID cases before it hit, and it affected the evacuation of people, and some people died because they did not evacuate. This is a problem. People don't want to go to centers where they're going to be crowded into, say, schools or dormitories because they're worried about COVID. And so these threats are piling on one another and exacerbating the end result. Next. This is Hurricane Harvey. This is I-10 in Houston. On the left-hand side, that's what it looked like before Harvey struck. And on the right-hand side is what it looked like during the peak of Harvey, as the storm surge and the waters from 60 inches of rain that fell on Houston gathered in a rather low-lying area of Houston. So these are real impacts of climate warming, because the jet stream slowing down allows these massive hurricanes to meander and dump rain and do catastrophic damage. Next. So 2020 looks like it's going to set an all-time record for tropical storms in the Atlantic, the Caribbean, and the Gulf of Mexico. We only have 2 letters left in the alphabet. And then it's going to start with the Greek alphabet. So I guess we might see Hurricane Alpha and Beta this year. We've had 20 named storms to date, and there's 2 or 3 systems out there right now in the Atlantic that look like they could fill out the alphabet for the first run through. Next. Here are all the paths of all the hurricanes up till yesterday. You can see they've been everywhere. The United States has had 4 hits now in the Gulf of Mexico. We've had a hit, several hits, direct hits on the East Coast, and we've been fortunate that none of these have been, except for Laura, category super hurricanes, 3, 4, and 5. And for the most part, they haven't hit the most populated cities. Let's hope our luck continues. Next. So the impacts of COVID, as I said, with explosive development cycles near a major coastline and a strike during an upsurge in COVID, this could be, we could have a mass casualty event as these things amplify each other. Evacuation plans need to be sufficient to protect lives. Shelters versus mass exodus versus shelter in place. What do people do? What do they do afterward when there's massive destruction and long-lasting power outages? I don't know that we're fully prepared for what could happen. Next. So as we look at the impacts of COVID so far, we know that the ability to evacuate in fires and hurricanes to prevent the spread of COVID has been iffy. There have been adjustments, renting hotels and putting people in hotel rooms and things like that. With the low hotel occupancy right now, that's been a successful strategy for the present. Knowing and using the COVID data to modify evacuation plans needs to be put into the system. As I said, when Hurricane Laura struck Mississippi, 300,000 people had already had COVID, and there were several new deaths because of that. And emergency services, such as hospitals, forest fires, and the sheer number of staging of 30,000 firefighters now on the fires is also an issue. Next. So summing it up, we know that CO2 and greenhouse gases are accumulating very rapidly since 1700, when the Industrial Revolution began. Over the last 1,000 years, I'm going to show you a chart here in a minute of the CO2 accumulation and the sea level rise since the Industrial Revolution began. I also want to just point out that so far this year, 2020 is on track to be the warmest year recorded in history for the global climate. And almost every year since 2000 has been in the top 20 warmest years. To give you an example, average temperatures are going up 1/3 of a degree Fahrenheit each decade since 1990, which is double the rate between 1880 and 2019. Next. So here's the CO2 graph and the other greenhouse gases since 1700. You can see around 1780, when the Industrial Revolution really kicked in, so did the concentration of greenhouse gases in the atmosphere. CO2 is the blue line, and the non-CO2 greenhouse gases are the red and black lines together. Next. Here's sea level. Here's a sea level rise over the last. CO2 rise over the last 1,000 years, and you can see the ramp after about 1900, when the Industrial Revolution happened. Probably the greatest thing that ever happened since then was the world went from 1 billion people to 8 billion, and so did the CO2 levels rise. Next. Here's the trend from the tide gauges and from our historic records of sea level rise back to 1880, roughly the start of the revolution. You can see that the sea levels have gone up about 9 inches around the world. It doesn't sound like a lot, but on a flat coastal plain, the water is coming in and eroding the coastlines ever more every year. Satellite measurements of the blue, and we've had satellites since 1982 roughly, measuring the sea level rise every day worldwide. Next. So sea level is rising about an inch every 7 to 8 years. The rate is increasing due to ice melt, and of course, as you warm the ocean, they expand. The storm surges from hurricanes and intense storms are going to be big events from now on. And red tides and harmful algae blooms are increasing, especially in Florida, due to temperature rises that are happening in the Gulf of Mexico that allow these toxic algae to bloom, bigger and bigger blooms every infestation that we get. And it's negatively impacting human health due to respiratory illnesses and the like. Heat waves are inflicting more and more health and economic damage. And the heat waves are also spawning these fires that are limiting air quality, and that's also a respiratory issue. There are many others, like crops suffering in grain belts that will move north, and with the forest close behind as the global temperatures continue to increase. Next. So the missing link in what we've been doing, in my view, is the science has come so far. We've gone from alchemy to chemistry in my career, and it hasn't had a huge impact on what we're doing in the world. And I think the reason is because there's a lack of trust and understanding in what science really means and how it can be used. In our age where we have fractured politics and conspiracy theories and internet and social media, the march of science really has been lost, and time is running out to use it for our benefit. The CAC is here to basically convert peer-reviewed science into understandable information that can be used for decision-making on a regional level to spur adaptation and mitigation of these really negative impacts. And there's lots we can do. I believe that restoring trust is the key to progress now, and that's the #1 job of the CAC. Next. Why I'm hopeful that we can do this. First of all, knowledge has doubled between 1990 and 2020, and it's increasing exponentially. Think about that. All the knowledge in the world that it took to 2020 to create has doubled in just 30 years. This means that by 2100, we'll have at least 3 times the knowledge that we have in the world today in the next 80 years. This event really dwarfs the largest change in the world to date, and that is the population explosion between 1890 and now. It only took 130 years to add 7 billion people, but it took millions of years to add the first billion. The climate economy is going to emerge in the United States, the most technologically advanced country in the world, and we can export that technology. It's the biggest opportunity for US economic growth that it's ever had. But we have to use the science in a way that spurs economic growth. Next. I believe that by 2100, with the advance of knowledge, that we'll be able to develop techniques to recycle the carbon out of the atmosphere and get rid of it. That sounds like a pipe dream right now, but 3 times more knowledge in 80 years gives us that opportunity. But in the meantime, we have to get from here to there. And that's why adaptation and mitigation on local and regional levels is so necessary now. So I hope you enjoyed this, and I hope you agree with me that taking a positive approach to climate warming is better than waiting for the seas to engulf us and the fires to burn us. It's time to get our head out of the sand and move forward. Thanks very much.
Thank you so much, Bob. This was really quite interesting and thought-provoking. Throughout most of the presentation, I was saying, oh, whoa, COVID is the first course and climate change is the second course in a pretty dismal menu. But I did like the very last slides that you have, because it kind of like whipped us out of this, negativism, and essentially brought us back with some important hopes. And you're right about the technological change can be an opportunity here. What's interesting is the fact that you said that we're moving away from the top-down approach, that the bottom-up approach from local, regional level becomes really very important. And that's, a major challenge, particularly when you see how stressed financially a lot of the states find themselves at the moment. But now it's time for everybody to join us on a Q&A session. So I would like you to essentially invite you to ask questions for Bob. What you do is at the bottom of your screen, you have a Q&A. You hit that and you write your question. There is no, at the moment, I know that for many Zoomers, the raise your hand possibility is always there, but not today. So it is really the Q&A. And while you are asking questions, one of them that I have found interesting is how do you view the difference of opinion and stance between the Republican and the Democrats in terms of how to tackle climate change? And I know that we all know that President Trump, for example, for the forest fires, is zeroing in on the forest fires and saying that this is a forest management problem, as you have pointed out, as one item, and ignoring the rest as, there's no climate change issue. But that's his view. More broadly, the Republicans versus the Democrats. Can you offer us some ideas?
Yes, I mean, I believe that, what's happened is, I don't know how we moved from gray to black and white. We went from black and white TV to color TV, and now we've gone back to black and white. And I mean that in the sense that we have polarization of opinions, and science really could care less about that, and the data doesn't care about it either. The fact is that they're both right for different reasons, and there's middle ground, but we have to work together, because both sides talk about things that are really valid, and we need all of those elements to be in the solution. So it's not that we can't do it, it's that we have to decide to do it. And the reason after a whole career dealing with politicians at a very high level, having been the lead forecaster for NOAA and director of the National Center for Atmospheric Research in Boulder, where we have 1,000 scientists and a $400 million budget. There's a lot of money coming in from government and from the US government. And what I can say is that we haven't had a consistent conversation. It's been very bumpy, and progress has been slowed because of all kinds of secondary issues. But I do believe that if I learned one thing in 22 years of government, is the government responds to the people, not the other way around. And so people are looking for the government to solve the problem. And in fact, the people will solve the problem and the government will follow. It's the opposite of what we've been doing. And that's why the CAC is taking a brand new approach to this.
That's very interesting. And I would think that to some extent it is extremely challenging, particularly when one tries to recover from these terrible events such as the human tragedy in the West, and also when you have these hurricanes. Just maybe putting together a few of these questions that are mostly on the climate per se. A couple of one is what can Canada, Mexico, and the US do to support the island nations as these hurricanes become more prevalent and also more violent? And in the same vein, but a different region, if you will, what is the climate warming effect on La Nina?
Yeah, so let's talk about mitigation for hurricanes in this. I mean, if these countries really want to invest in infrastructure, I have a lot that they can do. We need to soften the coastlines and make the coastlines bladders for storm surge. We've hardened all our coastlines, and now we have, like in Florida, $7 trillion of real estate on the beach. And so we've created the situation that we really don't want, but that doesn't mean that we don't have a lot of things that we can do with modern technology. I mean, look, in the Netherlands, they've actually increased the size of the country over 100 years. We know how to deal with high water, but we're not dealing with it. There hasn't been the will to do it, but we know how. It won't be perfect, but it will be a lot better. And we can, as working together with the Canadians and with the Mexicans and actually everyone in the world who is going to be impacted by a stronger storms, especially tropical storms, to share the techniques and the technology that we have, and to take down the barriers to using those technologies so that everyone can benefit in the quickest amount of time. We have to act in a coordinated way. We can't have every little town doing their own thing. We have to bring groups of local governments together to do regional-wide application to deal with, say, sea level rise and storm surges.
Yeah, that's almost like utopia, isn't it? But, you know, I see your point there. But, you know, precisely to that, can you give us maybe a roadmap of what would be adaptation and mitigation if you had carte blanche, for example, and you say, okay, I'm going to start now? What would be the steps?
Well, I'll give you a few examples just to make it clear. For example, we have to stop the increase in the rate of global warming. And the way we have to do that is we have to do two things. One is we have to lower our carbon footprint without crashing the world economy, because nobody wants to do that, or at least not very many people, I hope. But in the United States, for example, people would be surprised to know that coal now only makes up 20% of our energy production for the utilities, for electricity. Natural gas makes up 40%. Natural gas is a fossil fuel, but it's half as bad as coal from a greenhouse gas emission point of view. We could meet our Paris Accord agreed limit in the United States by simply switching 232 coal plants to natural gas plants. That's all we have to do. And we know how to do it. We're not doing it. You know, it's not the Paris Accord's fault. We don't need the Paris Accord to do that. We can do that. Regenerative farming, there's going to be a movie coming out on September 22nd called Kiss the Ground on Netflix. I hope everybody will tune in and watch it. It talks about regenerative farming and how we know how to farm now without releasing greenhouse gases into the atmosphere by doing it. Having big feedlots for cattle is a big carbon producer.
Yeah.
Deep tilling the soil takes the carbon out of the soil that has been stored there and releases it to the atmosphere every spring. With low tilling, we could release 10% of the carbon we're doing. Agriculture makes up 13% of all the carbon that we put into the atmosphere from all sources, more than cars in the world. So people don't realize we know how to solve some of these things now. We have to get on to doing it. So those are both mitigation. Adaptation is coastal zone manage our coastal zones for floods, new zoning to build buildings that can withstand 150-mile-an-hour hurricanes. We know how to do that. For 10% more cost, we can protect new homes from a Category 5 hurricane. It's not that much. And if we do it on a large scale, the cost will be lower. So I'll just give you those two things. There's hundreds of things.
Yeah, no, it's very
interesting. Doing them.
Yeah, yeah. And, you know, the interesting thing, for example, what we saw during the lockdown and air traffic having been reduced dramatically, the air quality had increased dramatically. So one can see that, well, those are not small steps, of course, because what it did, it, you know, contributed to the downturn in the economy, which is another challenge, right? Because as soon as you have a situation where you're in deep recession, that's when you do not take steps to follow other trends or to correct for other trends. And to that point, do you think that the COVID pandemic and the recession that it has created, do you think that that has changed the trend in the global warming?
I don't think it's changed the trend, because I think the other aspects that we're seeing, like these forest fires, put a huge amount of carbon into the atmosphere.
That's a good point.
And so, you know, we might have a slight leveling off, but, you know, we have to do things, like I say, not black and not white, but in the gray area. We should be able to live a great life with modern technologies by implementing these technologies in faster cycles. It doesn't take 50 years to put technology into the entire world like it used to. So the cycles need to be faster, and we need to make it available to everyone faster. And that's where the economic opportunity for the United States is. We don't see climate warming as an opportunity. We see it as a threat. But it is both. And that's why I really believe that converting the scientific information into actionable, trusted information will help spur that climate economy. And the US can lead that in the world if we want to. We just have to say yes.
And, you know, to that point, one of our participants, you know, pointed out that the Euro cold firepower in Hamburg, in Germany, is to go offline only after 5 years of being online. So this is an example, for example, that the electricity consumer and taxpayers for a policy that has nothing to do with the economic reasons per se. And that's not in place here. I would say that the general view here, as we've seen over the past couple of years for sure, coal industry versus other, right? And that probably will continue to some extent. So it's a fascinating situation. The climate change, is it a cyclical or is it a secular issue, phenomenon?
Well, I think that's a great question, and it's my favorite answer, because the answer is yes.
Great. You confuse us.
So the climate is always changing. It changes over thousands of years. And it's all due to the way the Earth rotates around the sun and the gravitational pull of the planets, and the makeup of the Earth itself is changing. The biology on the Earth is changing, the seas are changing, etc. So we've had climate change on the Earth ever since it started, and we're going to continue to have that. But the significant thing is the rate of climate change now is 100 to 1,000 times faster than normal. It's so fast that we can't adapt, not human beings, not the plants, not the animals, not our biodiversity. And so we're seeing everything moving at one time. And that is not something that can continue to happen over hundreds of years unless our technology advances so fast that we can really mitigate that. But I do believe that some of these things that we talked about, regenerative farming, switching to cleaner burning fuels, not necessarily 100% clean fuels, but better fuels, buys us time for the global solution to really evolve. And that's really what we need to do now.
Right, but this is really the difficulty, right? I mean, you're talking about earlier the regional and the local aspect, the buy-in at that level, and you elevate that to the government, and then go back in terms of the buy-in, if indeed it is more expensive, let's say in terms of taxpayers' money, to then a global cooperation. We've seen that movie before. It's very hard, unless we are all convinced that we can take, almost the modern monetary theory, in which case debt is not an issue, and we can, particularly for a country like the United States, we can issue debt because we are a reserve currency, and as a result, we could zero in on this. But then again, infrastructure, it's not just this, education, health, and on we go. And it's a real quagmire for policymakers, even if they were to, be on board with, okay, let's issue debt for this.
I think you have a great point, but I do think, I'm going to give you another quick example, and that is all these little towns around us have their own fire mitigation stuff going on. They all have their sea level rise stuff going on, or not. They all have their own protecting their beaches and their coastal zone. Every town does it different. Every time there's a project, they have to hire consultants looking at the same data that I look at every day, that I could give them if they were members of the CAC, that they could trust. They wouldn't need to pay for it 1,000 times every time they need it. So we have to create efficiencies in how we implement these things and how we organize them, so we're not just throwing darts, so that we actually have a more systematic plan. But that has to start from the ground up. It's okay to say, oh, well, we're going to cut carbon emissions by 30%, but it's voluntary. When you're living on the coastline and the sea level's coming up to your house, it's not voluntary anymore. It affects our lives. It affects our daily way of living. And we have the most fat in the fire, so to speak. But people now need to take this personally and act personally, but they have to know what to do. And we hope the CAC, which this is the first prototype, will expand and be in major communities around the United States and world over the years to help the local governments deal with their local problems.
Right. Well, time is moving on, not just for climate change and what we need to do, but also for our our event. And just very quickly to wrap it up for our audience, and I do apologize for all the participants who have put questions and we didn't have a chance yet or the time to address them all. So perhaps you can write them and we can send them on to Bob and he could answer them in writing. But just to wrap it up, what would be the 3 major takeaway, Bob, that you would give to our participants?
Well, the takeaways are that climate warming is not a theory. It's happening. The climate warming we're experiencing is at a rate we've never seen. And we've never measured in human history and beyond. We have 1 million years of pretty damn good climate records. And we've never seen anything quite like this. So it's real. The second thing is our approach to it has not resulted in enough progress in the time that we've wasted to, I think, a lot of it. And so we need to look at new ways to organize and to work together to get into this gray area where what you believe politically does not impact how the human race is going to end up surviving this crisis. We know what a pandemic looks like. We have a climate pandemic going on. It's the same thing. It's slower. It's not that slow. Look at what's happening this year. And look what's happened since 2017. It's getting more and more dramatic every year, and we can see it. How many people go out and play in the snow in the wintertime in New England? There's not that much snow anymore. And you can name where you are and think about what the climate was like when you were 20 years younger, 50 years younger, whatever it happens to be. And think about how different it is. And it's not a mistake, and it's not natural.
Well, Bob, thank you ever so much for this very interesting discussion, and we could have gone on for quite a long time here.
I know.
I know. All right. It's very interesting. It's very humbling as well. But you know, we hope to see you again very soon because this clearly is to be continued for sure.
Well,
so,
I would love to talk to you more often and longer.
Thank you so much, Bob. And before we close, I just wanted to let our audience know that next week, in the next week executive briefing, we have really another very exciting event, and that is on monetary policy with Jim Bullard, who I'm sure many of you know, the president and CEO of the Federal Reserve Bank of St. Louis. Registration is available on the website, the GIC website, that is. And that's to join us on Thursday, September 24th at 12 p.m. That's Eastern Standard Time. And as part of the David R. Kotok Global Health Series, David has established a very generous matching donation challenge. So any donation made will be matched dollar for dollar up to $50,000. So that means that if you have a donation of say $200, $400 will become $400 in value and impact. And rest assured that all these donations go directly towards bringing high quality content as a public service to our events for the remainder of the year. So to learn more about this, you can go to our website, and that's www.interdependence.org. I would say that as we conclude, I would encourage you to take 60 seconds to respond to our audience survey. This always is very helpful for us to essentially improve our series. Your feedback is very, very important. But most of all, I really want to thank you for having participated here with your questions. And again, apologies for not having been able to address all of your questions. With that, goodbye and see you soon.